Right now, a frozen fragment of the outer cosmos, 3I Atlas, is racing through interstellar space at over 93,000 miles per hour. Its path, unbound by the sun, slices through the solar system on a once-in-an-epoch trajectory. But new data from deep space telescopes reveals something unexpected. This isn't just another interstellar visitor. It's a colossal enigma, twice the size scientists predicted, and carrying chemical signatures never before seen in our corner of the galaxy. At the edge of human perception, where the blackness of space swallows even the faintest light, a moving point emerged, silent, relentless, and impossibly fast. The data from Pan-STARRS Observatory showed an object slicing through the void at over 93,000 miles per hour, its orbit unlike anything catalogued before. Within hours, astronomers confirmed what the numbers suggested. This was no native of the solar system. It had come from elsewhere, a drifter from the deep interstellar night. They named it 3I Atlas, the third known interstellar object to ever cross humanity's field of vision. But unlike its predecessors, its behavior broke the script of celestial mechanics. Most comets surrender to the sun's gravity, their icy shells disintegrating into long tails of vapor, yet Atlas defied expectation. As it plunged inward, nearing the sun's radiation, it brightened, not dimmed. It bloomed with energy, ejecting powerful jets of gas that hurled dust hundreds of thousands of kilometers into space. Telescopes from Mauna Kea to Cerro Paranal watched the spectacle unfold. Spectroscopy revealed a volatile cocktail of ammonia, methane, and carbon monoxide, frozen at temperatures below 230 degrees Celsius, compounds that had remained unaltered since the time of its formation. This was primordial matter, untouched by any sun older than the solar system itself. But within those readings lay something more perplexing. Molecular ratios that didn't match anything known in our galactic neighborhood. If Atlas had been born in the interstellar medium, it would have endured a journey of millions of years, bombarded by radiation and cosmic dust. Yet its surface gleamed with fresh ice, as though shielded, protected by a mechanism no comet should possess. Astronomers ran simulations, each ending in paradox. Its outgassing was too strong. Its spin too stable. The thermal data didn't align with any known sublimation model. Something inside Atlas was driving it. Something deep, self-sustaining, and entirely alien to classical thermodynamics. As the object continued its approach, crossing the orbital path of Mars, a global effort intensified. Infrared telescopes sought heat signatures. Radar arrays measured its spin. Every wavelength of light was parsed for meaning. Still, one question pulsed beneath every observation. Why was this frozen relic alive with energy? In the vacuum of space, where entropy reigned supreme, Atlas behaved as though it remembered warmth, as though it carried within it a dormant engine, or perhaps a record of something greater. Its brightness continued to climb, defying decay, whispering of processes unseen and unmeasured. Somewhere inside that ice, a mystery older than stars was stirring. What internal energy could fuel such defiance in the frozen dark? And could it hint at a process humanity has never witnessed in interstellar matter before? Across the black horizon of the cosmos, light is the only messenger that survives. It carries within it the coded memory of creation, the fingerprints of distant stars, the chemical whispers of worlds long extinguished. Through that light, astronomers begin to trace the journey of 3I Atlas. Its spectral signature, faint but precise, tells a story written not in words but in ratios. Isotopic differences in hydrogen and oxygen, deviations so stark that they defy any known region of the Milky Way's local spiral arm. In observatories scattered across the planet, from the frost-lined domes of Mauna Kea to the deserts of Chile, computers run billions of simulations, rewinding time through gravitational chaos. Each line of code attempts to reconstruct a path across a billion years of galactic drift. The data converges on a single conclusion. Atlas was born in a stellar nursery that once orbited a cooler, older star, rich in carbon dust and heavy elements, a place where planetary embryos collided and gas giants migrated inward like predators through a protoplanetary fog. In that violent ballet, Atlas was likely ejected, a casualty of celestial evolution, cast beyond its home star's gravity well, sent tumbling into the interstellar dark. But the longer scientists study its reflected light, the less the story fits. Its nucleus, by radar estimation, is far denser than any cometary body. Its rotational axis is erratic, changing by degrees over mere days, suggesting internal complexity, layers of mass not uniformly distributed. Most striking of all is its chemical resilience. Even after traversing light years of radiation and particle bombardment, Atlas's surface still glows with traces of complex organics, long carbon chains and nitrogen compounds that should have disintegrated eons ago. To preserve such fragile molecules, something must have shielded them, perhaps a crust of metal-rich ice, or a magnetic envelope generated deep within. Yet no natural model accounts for it. The paradox deepens with every observation. If its chemistry does not match our galactic neighborhood, then it is not simply from another system. It may be from another epoch. The universe, after all, has evolved chemically over billions of years. Each generation of stars enriches the next with heavier elements, rewriting the molecular possibilities of the cosmos. What if Atlas predates that enrichment, a relic from an earlier cycle of galactic life? Or what if it comes from somewhere beyond even that timeline, from a star system where chemistry followed a different set of initial conditions and perhaps a different definition of life itself? Spectrographs can measure only so much. The rest lies in interpretation and in humility. Somewhere in the uncharted gulf between probability and wonder, Atlas carries the ghostly trace of a place where the periodic table itself might read differently. And as its orbit draws it closer to the inner solar system, one realization begins to take shape among those who study it. 3I Atlas may not simply be a wanderer. It may be a messenger, a fragment of cosmic history, or perhaps a signal from a chemistry that evolved under rules no human has yet imagined. Could Atlas be a messenger from a star system where chemistry, and perhaps biology, evolved under alien rules? At 1.5 million kilometers from Earth, a silent eye drifts in the void. Its golden mirrors cold, its sensors tuned to wavelengths no human eye can see. The James Webb Space Telescope turns its gaze toward a faint, emerald point gliding across the black canvas of space, 3I Atlas. Within minutes, data streams back across the deep space network, a mosaic of photons, each one carrying the chemical secrets of a visitor from another star. The infrared spectrometers dissect its light. Beneath the familiar signature of frozen gases lies something extraordinary, the spectral fingerprints of polycyclic aromatic hydrocarbons, complex carbon compounds believed to play a role in the formation of life. They shimmer faintly beneath Atlas's icy crust, preserved in molecular lattices that should have been destroyed by the relentless radiation of interstellar travel. Yet here they are, intact, defiant, and ancient. On Earth, radio observatories resume where Arecibo once listened. Their successors, vast radar dishes spanning the deserts of South America and the steppes of Eastern Europe, bounce high-frequency waves against the passing giant. The echoes return sluggishly, delayed by the object's immense size. The data points to a nucleus nearly 12 kilometers across, nearly 3 times the size of the first interstellar visitor, Oumuamua. And with that realization comes a quiet shiver among those who study it. If Atlas is this large, then its gravitational coherence should make it predictable. Yet its spin remains unstable, shifting slightly every few hours, as though responding to forces not entirely external. Then, the anomalies begin. Microwave receivers detect pulses, brief bursts of radiation emitted at regular intervals. At first, they are dismissed as interference, an echo of solar storms or a quirk of instrumentation. But the pattern repeats, steady and unyielding. The emissions don't match the thermal outgassing of sublimating ice. They resonate at frequencies associated with rotating magnetic fields, something no comet has ever produced. Scientists propose theories, each more improbable than the last. Could Atlas contain a ferromagnetic core? Could charged particles, trapped since its birth in a distant nebula, still oscillate beneath its surface, releasing ancient energy? Or is it a relic of a process unknown to terrestrial physics, a fragment from a system where the rules of magnetism evolved differently? The Webb's infrared scans deepen the mystery. Certain emission lines display phase shifts inconsistent with reflection alone. Something within the object seems to absorb and re-emit energy, with conscious regularity, as though reacting to sunlight not as heat, but as information. Across control rooms, silence falls. The data is too consistent for error, too ordered for coincidence. The comet's behavior now blurs the boundary between natural and constructed, between formation and design. If the universe once birthed matter capable of encoding energy patterns, then Atlas may not just be a rock of frozen gases. It could be a memory, preserved in magnetic rhythm, humming through the darkness. The more they measure, the less it behaves like a comet, and the more it resembles something engineered by forces unknown. At 0.84 astronomical units from the Sun, the frozen body of 3I Atlas awakens. What was once a silent wanderer now blazes into brilliance. From the vacuum between worlds, a surge of solar radiation strikes its surface, vaporizing carbon compounds into jets of gas that spiral outward in dazzling motion. Telescopes lock onto the spectacle as its coma, the halo of vaporized ice and dust, transforms into an emerald sphere, so bright it rivals the luminescence of Venus. The source of the color is known, diatomic carbon C2, reacting violently to ultraviolet photons from the Sun. But no comet has ever produced this level of emission. The intensity is off by orders of magnitude, 1,000 times brighter than expected, as though the molecule itself were resonating, amplifying light far beyond theoretical limits. Scientists model, recalibrate and simulate. Every result ends the same way as impossible. For nights on end the world watches. The green arc of Atlas stretches across the dawn sky, a living pulse of light cutting through the atmosphere's thin veil. Its tail extends for millions of kilometers, shimmering like a spectral vein feeding energy into the solar system. Cameras capture the eerie glow reflected off oceans and mountain peaks, while magnetometers record subtle fluctuations rippling through Earth's magnetic field, perturbations that seem to echo the comet's rhythm. Something in the plasma tail is interacting with the planet. Not enough to harm, but enough to touch, a whisper of electricity across the magnetosphere, like a cosmic handshake. For the first time in recorded history, Earth is brushing against matter formed around another star. The experience is more than scientific. It is existential. For a fleeting moment, humanity feels the scale of its connection to the wider universe. The realization that even across interstellar distances, the fabric of space remains a single continuous web. Yet beneath the wonder, the instruments see more. As Atlas swings around perihelion, its closest approach, the radiant green begins to flicker. Telescopes capture irregular patterns along its nucleus, dark fissures opening, jets shifting direction, and clouds of material dispersing unevenly. Something is breaking apart. Spectroscopic readings detect metallic traces mixed with the vapor, nickel, iridium, and silicates rare even in meteorites. The comet, it seems, is shedding pieces of itself into space. At first, it appears to be a natural disintegration, the thermal stress of solar heat tearing it from within. But one fragment behaves differently. It separates from the main body at a controlled velocity, spinning slower than debris should. Observers track it as it follows a slightly altered path, one not purely dictated by gravity. Calculations confirm the trajectory, a direct intercept with Earth's upper atmosphere in less than 4 weeks. As Atlas drifts onward, its fading light dissolves back into the fabric of night. Yet across radar stations and orbital observatories, attention shifts to the fragment trailing behind, a smaller echo of something vast and unexplainable. The spectacle has ended, but its consequences have only begun. For in the wake of the green sky, a silent object now approaches, a shard of interstellar mystery on a collision course with the blue world below. Yet, as it swings past, sensors detect an anomaly. Atlas is shedding fragments, and 1 API at 0217 UTC, the night sky over the central Pacific ignites. A streak of white fire cuts through the stratosphere, brilliant enough to cast shadows across the ocean waves 200 miles below. Tracking stations from Guam to Hawaii register its trajectory, a fragment of 3I Atlas, no larger than a house, descending at 58,000 kilometers per hour. The air around it compresses and ignites, generating a plasma sheath hotter than molten iron. For a few fleeting seconds, the heavens themselves seem to split open. Then, silence. The light vanishes as abruptly as it appeared. Radar loses contact. What remains is an invisible storm. Atoms, ions, and charged dust scattered across the upper atmosphere, spiraling downward into the sea. Military satellites classify it as an aerothermal disintegration event, but in scientific archives, it becomes something else. Event Atlas V, the first confirmed atmospheric entry of an interstellar object fragment. Minutes after the flash, sensors anchored deep in the Pacific abyss detect a signal, not light, not sound. A brief coherent burst of radio frequency energy, lasting less than 2 seconds, spanning a bandwidth no natural plasma emission has ever occupied. It's faint, structured, and perfectly timed with the fragment's final descent. Then nothing. In the following days, oceanographic vessels converge on the impact zone. Drones sweep the seafloor with magnetic resonance scanners, tracing the faint residue of what fell. Within the sediments, something strange emerges. Microscopic grains, glassy and metallic, glinting under scanning electron beams. Laboratory analysis confirms they are not terrestrial. The isotope ratios of carbon, silicon, and iron are unlike any known meteorite. They carry silicon carbide lattices, but arranged with unnatural regularity, symmetrical beyond statistical chance, as though shaped by intention. Under transmission electron microscopy, the particles reveal interlocking carbon chains forming quasi-crystalline matrices. Their repeating geometry bears a mathematical precision seen only in engineered materials. The pattern isn't random, it's algorithmic. Every line, every fold mirrors the same ratio, F, the golden constant. The scientists hesitate to speculate. Some argue the structures could be products of exotic cosmic conditions, formed under pressures or magnetic fields unknown to Earth. Others whisper of something deeper. If the symmetry was not born of physics, then perhaps of purpose. Could the fragment have carried encoded order, a kind of cosmic language written not in sound or symbol, but in matter itself? Spectroscopic reconstruction of the disintegration trail adds another layer of mystery. As it burned, the fragment emitted harmonic pulses, rhythmic bursts of ionized energy that matched the same intervals found in hydrogen's emission spectrum. Hydrogen, the first element, the universal constant. It is as if the fragment was speaking in the frequencies of the universe's most ancient tongue. On the surface of the ocean, all evidence of the fall is gone. Yet deep beneath, the particles continue to drift, tiny artifacts of something not made here, suspended in eternal descent. The story of 3I Atlas, once a tale of cometary ice and cosmic dust, now begins to blur the line between the physical and the intentional. For what if this fragment is not merely debris, but the first message ever delivered by matter from beyond our star? Sounds to be on a direct path toward Earth's atmosphere,